Hello, my name is Satisha KM, lecturer, Electronics and Communication Department, Karnataka Government Polytechnic, Mangalore. I would like to welcome you to ARM Controller online class, Unit 1, ARM Embedded Systems and ARM Processor Fundamentals. In today's class, we can discuss embedded system memory, that is session number 10. In previous class, we discussed pipelining architecture. Fetching the next instruction while other instructions are being decoded and executed is called pipeline, which speeds up the execution. In previous class, we discussed comparison of sequential instruction processing and pipelined instruction processing. In sequential instruction processing, number of cycles needed is equal to number of instruction into stages, that is 5 into 3. If 5 instruction is processed, then 15 cycles are needed. In pipeline instruction processing, number of cycles needed is equal to number of instruction plus stages minus 1. If we are using 3-stage architecture, then number of instruction to execute 5 instruction is equal to 5 plus 3 minus 1, that is 7 cycles. In today's class, we can discuss embedded system memory. Embedded system memory characteristics are hierarchy, width, and type. We will discuss one by one in next slides. Next, we are studying how ARM is suited for DSP type function, that is digital signal processing type function. Next, justify how ARM is suitable for mobile applications. Next, we are studying the features that improve the code density in ARM architectures. And next, we can see the MCQ under this embedded system memory topic. Memory. An embedded system memory must have some form of memory to store and execute code or data. You must compare price, performance, and power consumption when deciding upon memory characteristics such as hierarchy, width, and type. If memory must run twice fast to maintain the desired bandwidth, then memory power requirement may be higher. First characteristic, that is hierarchy. All computer systems have memory arranged in some form of hierarchy. Intended to processor, there is an option to improve the memory performance. In this diagram, we can see there are three types of memories. One is cache, another one is main memory, another one is secondary memory. In x-axis, it is given as memory size. In y-axis, given the performance or cost of these memories. In this, we can see this cache is in performance wise higher performance memory, that is fastest memory is cache. But this cache is located in between the processor and main memory. So nearer to processor, cache is placed. Next, slowest memory is secondary memory. Performance wise, the slowest memory is secondary memory. This secondary memory is placed far away from the processor. That is, after main memory, the secondary memory is placed. Another one we can see, closer memory is to the processor core. If memory is to the processor core is closer, the more it costs and smaller its capacity. The cache price is more and smaller the capacity. You can see less than 1 MB. It is in KB. Cache is always in KB. Cache is placed between the main memory and the core. Cache is placed between the main memory and core. It speeds up data transfer between the processor and main memory. If cache is there, the execution time is less. The main memory is larger than this cache memory, around in embedded system 256 KB to 256 MB, depending upon application, generally stored in separate chips. Load and store instruction are used to access the main memory in ARM core. Secondary storage device is largest memory and slowest memory. So hard disk drives and CD-ROM drives example for secondary storage device. So size of secondary memory is large compared to main memory and cache memory, 600 MB to 60 GB. Width. The memory width is the number of bits memory returns on each axis of the memory. Typically, it is 8-bit. If 8-bit width memory means at a time we can access in 8-bit number. In one axis, we can access 8-bit number. 16-bit memory means in one axis, we can access 16-bit. The memory width has direct effect on overall performance and cost ratio. If you have an uncached system, 32-bit ARM instruction and 16-bit wide memory. In ARM, if you are using 16-bit wide memory, then processor will have take two memory fetches. In one memory fetch, the first 16-bit will access. In second memory fetch, next 16-bit will access. In first memory access, higher data, higher word will come. In next data, lower word will come. So therefore, if 32-bit ARM instruction is there, then if you are using 16-bit memory chips, then we need two access, two cycles to fetch 32-bit instruction. So this obviously has effect reducing the system performance, but benefit is cost is less for 16-bit memory. Width. In contrast, if core executes 16-bit instruction, that is thumb instruction, it will achieve better performance in 16-bit because only one fetch is enough to load 16-bit code. If higher is the performance in result of the core making only single fetch from the memory to load an instruction. Hence, using thumb instruction with the 16-bit wide memory devices provides both improved performance and reduced cost. You need a higher performance means if processor executing 16-bit instruction, then 16-bit memory is needed. If processor is executing 32-bit instruction, we need 32-bit memory. Then in only one cycle itself, we can fetch the data and we can improve the performance. For example, ARM 32-bit instruction. If we are using 8-bit memory, then 32-bit by 8, 4 cycles are needed to fetch 32-bit instruction. If we are using 16-bit memory, 32 divided by 16-bit, only 2 cycles are enough to load the data from the memory. If 32-bit instruction, you are using 32-bit memory, then only one cycle is enough to get the data from the memory. If you are using 16-bit instructions, then if you are using 8-bit memory, you need 2 cycles, 16 by 8. 16-bit instructions, if you are using 16-bit memory, in only one cycle itself, you can fetch the data from the memory. If you are using 16-bit instruction, 32-bit memory, then in one cycle is needed to fetch the data from the memory. Next characteristic, memory characteristics, type of the memory. There are many different types of the memory. In embedded system, we are using several types of memory are listed below. Read-only memory, that is called ROM, flash ROM, dynamic access, random access memory, DRAM, static random access memory, SDRAM, SRAM, synchronous dynamic random access memory, that is SDRAM. These are the several types of memory generally we are using in embedded system. Next we move on to how ARM is suited for DSP function, that is digital signal processing function. A system on a chip is integrated circuit that integrates all computer components of the computer or other electronic systems into a single chip. A single chip contains both hardware and software components. Following components are the part of single chip. CPU is there, DSP unit will be there, DMA will be there, NAC will be there, audio and video controller will be there, USB controller will be there. So we can see the block diagram of system on a chip. DSP is an interesting thing. This component used for image decoding, which would be otherwise be done by CPU. So ARM CPU will be there. Separate digital signal processor will be there. This processor will do the DSP action, and that will be given to the ARM processor. Therefore, it will speed up the processing. DSP processing will be speed up by the digital signal processing, the add-on processor. So all these blocks are embedded in one integrated IC and given as system on a chip. So ARM is suited for DSP function by using this SoC, single system on a chip. Next, how ARM is suited for mobile application. Smartphone means so much to so many people. It has become a universal device now. So it can be used as a navigation device, entertainment device, and payment device now. So smartphone combination always with the compute and connectivity has changed the world into a digital world. ARM has delivered more for less by increasing underlying the CPU performance by 100x and GPU performance by 300x since 2009. So in much of the application, mobile devices, ARM is used as a core. ARM innovation extends beyond CPU and GPU to many other components within the smartphone. Justify the features that improve the core density in ARM. High core density for limited memory and physical size restriction. If high core density is there, then the memory, if we are having limited memory, then high core density is expected. The ability to use slow and low cost memories will improve the core density. Reduced if we are having code are in less in size means reduced die size is enough to manufacture the cost and accommodating more peripherals on the same small die. ARM will support 16-bit thumb instruction so that code density we can increase using thumb instructions. We can summarize the points discussed in this session. Embedded system memory characteristic. One is hierarchy, width, and type. So in this diagram, we can see there are three types of memory: cache, main memory, and secondary memory. The cache memory is as the fastest memory, secondary memory is the slowest memory. Cache performance is very high, speed is very high, secondary memory performance is less. Cache cost more and secondary memory cost less. And cache is a small memory and secondary memory is a large memory. We can see the width of the memory. If we are using 32-bit data and we are using 8-bit memory, then we need 4 cycles to fetch the data from the memory. So the same way, if you are using 16-bit, only 2 cycles enough. If you are using 32-bit memory, then only 1 cycle is enough. If you are using 16-bit thumb instruction, then if you are using 8-bit memory, 2 cycles are needed. For 16-bit memory, 1 cycle is needed. For 32-bit also, 1 cycle is needed. These are the typical width of the memories: 8, 16, 32, and 64. We can discuss some of the multiple choice questions under this topic. Identify which is not specific memory characteristic. One is hierarchy, another one is width, third one is the temperature, fourth one is type. We can discuss the which is the not specific memory characteristic. Temperature is the not memory characteristic, therefore C is the answer. Second question, identify which is the fastest memory: main memory, cache memory, secondary memory, flash memory. We already discussed this topic. Cache is a smallest memory, it costs more and fastest memory in memory section. And secondary memory is largest memory. B, cache is the answer. Third question, identify which memory has less performance or cost: main memory, cache, secondary memory, flash. In memory segment, the cache is highest cost memory. The small size and performance is higher. Main memory is in between and secondary memory has less cost and less performance. The answer is C, secondary memory. Fourth question, identify which memory has largest memory size. In size, which memory has largest size? Main memory, cache, secondary memory, flash. We already discussed the secondary memory is the largest size and cost is less. Next question, how many cycles needed for ARM processor 16-byte memory chip for fetching ARM 32-bit instruction? 32-bit instruction is that we are using 16-bit wide memory. Therefore, how many cycles are needed? Option A 1, option B 2, option 3 C, option C is 3, option D 4. 32-bit instruction and 16-bit wide. 32 divided by 6, that is 2. 2 cycles are needed to fetch the instruction. Answer is B, 2. So we can recall the first session to 10th session one by one in short way. In session 1, the topic is Introduction to ARM processor. So we studied Advanced RISC machine. The full form of ARM is Advanced RISC machine. In that session, we studied history of ARM. ARM is developed in between 1983 and 1985 by Korn Computers Limited. In 1990, ARM Limited was developed So that owned by Acorn, Apple and VLSI. In this figure, we can see the ARM limited companies. Next, we discussed the ARM different versions. That is version 1, version 2, 3, 4, 5, 6, 7, etc. These are the different versions and these are the years where they existed in the world. In next session, we discussed risk design philosophy and ARM design philosophy. Disk design philosophy implemented with four major design rules. One is instruction, pipeline, registers, and load store architecture. ARM design philosophy. So ARM design philosophy features are a large uniform register file, load store architecture, 32-bit processor, instructions are 32-bit long, good speed or power consumption ratio, high code density. Along with that, these are the risk features. Along with that, non-risk features are inline barrel shifter is there, condition execution will be there for each instruction, enhanced DSP instructions are supported, variable cycle execution for certain instructions are supported. Next, in next section, we discussed embedded system hardware. This is the block diagram, which is the embedded system using ARM processor. And next we studied AMBA bus architecture, that is advanced microcontroller bus architecture. In next session, we studied embedded system software, that is device drivers, initialization, operating system, application. These are the building blocks of embedded system software. In next class, we studied ARM data flow model. How data will move from one block to another block in ARM. There are sub-blocks in ARM block diagram, register file, barrel shifter, ALU, address register, MAC, instruction decoder, sign extended unit, etc. In next session, we discussed topic registers. There are several registers, 32-bit registers are there in ARM architecture. All are 32-bit registers. R0 to R12 are called general purpose registers. R13 is called stack pointer. R14 is called link register. R15 is called program counter. And next we are having CPSR, current program status register. In session 7, we studied the structure of the CPSR, what and all control bits are there, how many flag bits are there. We studied the structure of the CPSR. Next, we studied the processor modes. There are 7 modes are there. Out of these 7 modes, one is non-privileged mode, that is user mode. Rest all modes are privileged mode. In next session, we studied banked registers. In total, in ARM7, we are having 37 registers. Out of 37, 20 are hidden from program in different times. These are called banked registers. So here, the one by one mode is given. Number of bank register used in this mode is given and registers names are given. In user mode, total 17 registers are available, R0 to R15 and CPSR. In system mode, there are 17 registers are available, R0 to R15 and CPSR. In FAQ mode, total 8 registers are available, R8 to R14 and SPSR. In all other modes, R13, R14 and SPSR are available in banked registers. In next section, we discussed pipeline. Fetching the next instruction while other instruction being executed and decoded is called pipeline, which increase the speed up the process execution process. These increase the performance of the system. So next we studied the comparison between sequential instruction processing and pipeline instruction processing. The number of cycles needed in sequential processing is number of instruction into stages. Number of cycles needed in pipeline process is number of instruction plus number of stages minus 1. In this topic, today we discussed embedded system memory. In that, embedded memory characteristics are hierarchy, width, and type. So these graph will show the memory size, the cache, main memory and secondary memory, the memory size and performance graph. So this will give the how many cycles needed to fetch the 32-bit instruction in case of 8-bit, 16-bit and 32-bit memory. Thank you.